Next up, we have Eve, a fairly experienced speaker on the scene. So not to build you up or set expectations, but hopefully a really interesting talk here about connecting AI to reality. So give it up for Eve.
Thank you for the introduction, Danielle, and I really want to go to the Butter Museum now. My name is Eve Brennan. I'm delighted to be here today. This is actually my second conference this week, but I've been really excited for this one. It was actually Women Techmakers Belfast where I did my first ever conference presentation a few years ago, so it holds a really special place for me. And I really love the theme this year of breaking the pattern. I didn't really like the International Women's Day one, Give to Gain. It just felt like women already do so much and give so much, and it is actually recognised that women do the most hours of labour globally, yet only receive 28% of the income. So to me, it felt a little bit tone deaf, although I can get behind the whole idea of generosity and community. So gain from what you give, I think, would be a better tagline. But today my talk is about not just how, but when to build an MCP server from scratch. Last year I was seeing all these MCP servers pop up. There was GitHub, Terraform, AWS, Kubernetes, and although they are like really helpful for my job, I was having these visions of something going rogue and like nuking with the GitHub organization and exposing a customer database. So I felt like I really needed to understand how it worked under the hood before I could, in good faith, use one in my role. And as I gained a better understanding, I realized that it's actually not that challenging to build one if you have a good use case. So I identified a problem area in my personal life and set out to build my own MCP server. So today I'll be sharing some of the learnings from that process with you. We'll touch on software architecture, tooling, security, and how to get the most out of any MCP servers that you have in development. My aim is that you'll walk away with a better understanding of how the internals of agentic AI work. But why should you listen to me about it? Career-wise, I started my career as a software developer before moving into the world of cloud and DevOps. By day, I work for Business Insider, one of the sponsors today in the cloud platform team. Little shout out, we actually have a role open, so if you want to come and work with me, please come chat to me afterwards. And outside of working hours, I'm involved in the tech community and different conferences and events. I help organise the DevOps Belfast event, and another little plug, we have our next event coming up on the 25th of March, so save the date. But the photo up here, the one of me as a 5-year-old, it's not coincidental that I've included that. That was about a year before I was diagnosed with a condition called type 1 diabetes. And I'm very fortunate that what once was a death sentence only 100 years ago is a relatively treatable condition, albeit still with its challenges. And it was these challenges that inspired me to build an MCP server to help diabetics record their carbohydrate intake and analyze trends in their blood sugar levels. But before we talk about that, I want to make sure that everyone is on the same page about what an MCP server is, because I feel like I've said MCP like 20 times already. Over the last couple of years, models have gotten pretty good at reasoning, planning, and calling tools. But every app needed its own custom integration. Every developer was implementing the same let the model talk to tool over and over again. That made it really hard to share integrations across vendors, and it was really holding back the whole wide-scale launch of AI agents. In November 2024, Anthropic came along with a solution for this, the Model Context Protocol. It's an open standard for connecting agents to external systems through a common protocol instead of one-off adapters. The common analogy that gets used is to think of it like a USB-C port for AI applications. Since launch, MCP has picked up a big ecosystem. Many vendors have standardized on it as a default way to access tools. There are now software development kits in most major languages, and this is reflected by the thousands of MCP servers out there. The availability of the SDKs and the compatibility is what makes it pretty approachable to build your own MCP server or client. So in my opinion, type 1 diabetes is a little bit misunderstood, but I feel like it's necessary to have a little bit of understanding of it to be able to see why AI is helpful for it. You know, I was 7 years old the first time someone made an uneducated comment about my weight, even though weight has nothing to do with type 1 diabetes. I've also had people grab food out of my hand, like I have a sugar allergy, you know, telling me I can't eat it. So I want to just explain it a little bit more. Type 1 diabetes is an autoimmune condition in which the immune system destroys the cells that produce insulin. Without insulin, your body can't turn food into energy, and so your body starts to rapidly break down fat, and that's very, very dangerous. To prevent that, at the first symptom of type 1 diabetes, you need to start insulin replacement therapy. And this is done with either multiple daily injections or with insulin pump therapy. And this is a lifelong commitment. It's not a curable condition. The amount of insulin that you need to take every day and at different times is different for every diabetic. There is no set dose. To calculate our individual dose, we calculate the ratio of units of insulin to grams of carbohydrates. There is a lot of toil and trial and error involved with this process. You have to keep a food diary and you have to record how much each meal impacts your blood glucose levels, and then do a whole mathematical equation to get your basal and your bolus rates. There's a lot of jargon involved. And like I said, a lot of trial and error. To make sure that we are taking enough insulin, diabetics need a way to test our blood glucose levels. When I was diagnosed, the only way to do this was with a finger prick blood test, but continuous glucose monitors, which you can see up on the screen in the bottom right corner, are now the standard way to do this. And oh my God, they are life-changing. As far as I'm concerned, they are the biggest technological advancement in the last couple of decades. It allows me to see in real time what my blood glucose levels are on my phone, and then I can get alerted to any high or low blood glucose levels and fix them accordingly. But here's the thing, blood sugar levels, it isn't just influenced by what you eat and how much insulin you take. It's also influenced by stress, sleep, hormones, exercise, even the weather. You know, a really good example, thinking back to Saba's talk, I remember once getting paged into an incident in, I won't name the company, but we were under cyber attack. And I remember just looking at the graph of my blood glucose levels afterwards, and there was just a big spike in them from all the adrenaline from trying to deal with that. So as diabetics, we have to continually spot the trends and adjust accordingly, which is what I wanted to make a little bit easier with an MCP server. With the combination of continuous glucose monitors and insulin pumps, there has been the rise of what is referred to as the closed-loop insulin pump. Closed-loop pumps connect to a continuous glucose monitor, like the one I showed on the previous screen, and they adjust insulin delivery in real time based on your blood sugar readings. Unfortunately, these aren't widely available, you know, not just in Belfast, but worldwide. There can also be other issues like user experience issues, because you know, a lot of people who are diabetic have visual impairments or dexterity issues, which aren't always taken into account. But there is, however, a whole open source ecosystem of diabetes tech, and it's driven by people who, citizen developers, I've heard that term a few times today, you know, who decided not to wait for the pharmaceutical industry to meet their needs. One of the most inspiring parts of that movement, in my opinion, is the Night Scout Foundation. It's basically the Linux Foundation, but for diabetics. You know, they've built open tools that let diabetics access, visualize, and share their glucose data, and even create their own closed-loop insulin pump systems. I started using these two pieces of their software last year while on this journey to build an MCP server, and it ended up becoming the external system that my MCP server makes accessible to AI agents. So having spoken a little bit about what some of the problems of managing diabetes and how an MCP server might address that, here's actually a pre-recording of while I had it in development. So it's just a pre-recorded demo I'm going to talk over. In this case, you'll see me using GitHub Copilot and VS Code to interact with the MCP server. You'll see me use natural language to ask how on Halloween impacted my blood glucose levels. And it's a pretty simple example. It's not that complex. But you can see then that Copilot knows to fetch the get blood glucose tool. And that way it can fetch the data and then analyzes it to tell me that once it comes up, you can see it's calculating the averages and medians, and it says, actually, your blood sugar levels were okay over Halloween, apart from a minor hypo. So afterwards, so having looked at all of that, while I was doing this, I was sitting munching through some leftover Halloween sweeties. That's why Halloween was on my mind. I decided to use an MCP server prompt, and I don't think these get a lot of love, but it's basically just a prompt with user input. So I've already specified things like how to, told it how to calculate how many carbohydrates are in something, and told it different rules like, I'm in the UK, this is a good source for online nutritional information. But really, really useful for prompt engineering because it just allows you to create that template and then you just fill in the gaps. And then finally in the recording, having gotten that estimation, you'll see me ask Copilot to upload the estimated carb count to my Night Scout app on the open source applications I mentioned before. And that's using the add carb treatment. So from there, once the carbohydrates are uploaded, the closed loop pump system can calculate how much insulin to give me. Without this MCP server, I would have to rely on something, probably a paid subscription of MyFitnessPal, and then spend the time searching for all the individual foods you might have in a meal, and then manually count that up before entering that into the app. So, you end up with 2 or 3 apps open just to try and do that. And actually, a lot of insulin pumps, you can't actually interact with them from your phones. Then you actually need a separate device altogether too. So it can be a bit of a headache. Something to call out in this is that you probably saw, manually approve every tool call. And that's so I can verify that it's doing sensible things because, it's pretty serious when you're interacting with medical systems. There needs to be a mechanism for manual approval. And that makes MCP quite good for sensitive use cases like this. This MCP server could be used to spot patterns in the times that our blood sugar levels are out of range and find the causes that the human misses. In the long run, I would like to integrate this with other data sources, linking glucose data with real-world events, so I can uncover those correlations and manage diabetes more intelligently. This is a remote MCP server, so it wasn't actually running on my laptop. It was actually running up in AWS. You don't really need any special setup to deploy a MCP server remotely, but there are some dedicated MCP server hosting options out there on like Fast API and Cloudflare. But yeah, you can host it wherever you want. So let's unpack how it was built. Architecturally, MCP puts a server in the middle. That server in the middle defines the tools, resources, and prompts that can be used by the MCP client, and it also handles authorization. It's one extra hop in your architecture, but you get a single place for governance, logging, and a consistent interface over your external system. Whilst this is generally a one-directional flow in requests, the server can reach back out to the client for structured user inputs, a feature called elicitation, which doesn't have a lot of traction just yet, but it enables users to enter form data or be directed to external URLs, which will be really helpful for agents to be able to make payments to each other in the future. So something that you might have also noticed is that I did mention features that aren't available in ChatGPT. Whilst MCP is widely adopted, it isn't fully supported. It is generally just a tools function that gets support from all the big vendors. So while you saw me use an MCP prompt in the demo I just did, when I show you how this works in ChatGPT later on, you'll see that only tools are available. Now, I couldn't call it a balanced talk if I didn't mention that there are some criticisms of the Model Context Protocol. My biggest gripe is that lack of support by AI assistants, which I already mentioned, but that's not really, a problem with the protocol itself, more so just the vendors. The biggest and most common criticism that's made against it is that it's simply an API wrapper and an unnecessary abstraction. And yes, it does commonly get used like that. But I would argue that's poor architecture decisions. The other criticism, which I do think has weight, is the security concerns. I have them. I spoke at the start about how I was terrified of it, like blowing up, some of my accounts and work. Everyone should have them. I'm going to talk about how you can actually use MCP as another layer of security for some of your external systems. But it is so important to be cautious of the MCP servers online. Because if you download or use a compromised MCP server, you could inadvertently give it access to very sensitive information and it could wreak havoc. The MCP steering committee has created an MCP registry to govern some of this. So I would definitely encourage you to check that out if you want to start using MCP servers in your workflow. If large language models are going to be real software platforms, which I think we are starting to see become more and more true, they need to have a stable interoperability layer. MCP is the first serious attempt at this, but this area is going to continue to evolve. But I will draw your attention to some of the alternatives. So the first alternative, and it is a little bit niche, I don't think it is adopted widely, is the Universal Tool Calling Protocol. And it solves the same core problem of how do agents call tools from external systems. While an MCP server mediates the connection to an external tool, with UTCP, the external system publishes a manual describing how to call the tools, and the agent then calls the tool's native API directly with no intermediate server required. UTCP is pretty good if you want to call an API as is. But it isn't as widely supported, and it does require ownership of the external system. As I understand it, it only supports APIs, which does limit the types of external systems it can connect to. Alternatively, if you're shipping an end-to-end app where the business logic and the model calls all live in one monolith, you don't necessarily need either protocol. The app can do your business logic, get a result back, and then add it to the context window, and then make the request to the LLM and vice versa, all in the same app. Where MCP and UTCP really pay off is when you have multiple clients and you care about reuse across those different clients. So for the MCP server that I built, the external system is open source, but I use their platform as a service, so it's not really feasible for me to make changes to it, and nor do I particularly want to when it's doing something so important for me. So it's not really feasible for me to make those changes. I can use its API, so I could make my own app and do direct tool calling, but I wanted to be able to avail of one of the existing clients like ChatGPT or Claude, so in my case, MCP makes a lot of sense. So to actually get started with building MCP servers, there are a bunch of tools and libraries out there. There's lots of different methods. You don't necessarily need to write code if you don't want to. At its core, MCP runs on JSON RPC, and most developers don't want to handcraft JSON RPC messages, so a good library or framework makes a lot of sense here. The main two libraries that get mentioned are the official MCP SDK and FastMCP. The official MCP SDK is the reference implementation. It's what's referenced in all the MCP docs. It's fairly bare metal, but it comes in a variety of programming languages. Meanwhile, FastMCP is a Python framework, and I really like this one. It has support for the auth providers, testing framework. It can even generate MCP servers just based on an API spec. If I were to start the project all over again, I would have used it, but I chose the official SDK. If you want to stay away from code altogether, there are low-code and no-code options. I would advise you to take a look at AWS Agent Core, FastMCP Cloud, and there's also a couple of Cloudflare offerings too. And it's interesting talking about library choices in 2026 because we're increasingly viewing code as disposable. As someone who has always enjoyed the craft of writing code, that does come as a shock to the system, but the mindset we need to adopt is to perhaps to view code in the same way that we view compilers as a means to an end. So the takeaway, I guess, is to choose the library that meets what you're trying to achieve. So next, I'll share a short code snippet that defines a tool. So tools in MCP are designed to be model controlled, meaning that the large language model can discover and invoke tools based on their metadata. So the first thing you need to do when creating an MCP tool is define the metadata. Similarly to a typical function in TypeScript in this case, you can define the parameters. So for my get glucose entries tool, I've added the start date and the end date as the input schema. I've also specified the format and the format of the output of the tool. And I've defined the title and a description. This way, the large language model can see all the metadata when the session is initiated, and it will use it to determine when the tool gets called. When we look at the input schema, we want to consider the risk of prompt injection. Similarly to SQL injection, we don't want the client to be able to send arbitrary strings or structures. So I've used SOLID to validate the input in this example. Once you have the metadata defined, you can move on to creating the actual business logic. So I mentioned one of the criticisms about MCP servers just being API wrappers. Good MCP servers don't just wrap APIs, they curate them. A common criticism that you'll hear is that MCP servers bloat the context window, and LLMs are a lot less effective when there is a lot of noise. So for example, Night Scout's entries endpoint returns a ton of stuff, collection IDs, timestamps, device info, all pretty irrelevant for my use case. So what I did in my output schema, I stripped the noise and kept only what mattered. It is worth mentioning that if your MCP server has access to an external system, like in this example, you really need to lock down the permissions that the MCP server has in the external system with RBAC. So for example, I created a role in Night Scout that is limited to reading blood glucose levels and creating food records, but it can't access any admin issues. In GitHub, their MCP server, which I mentioned earlier, I have a personal access token for that, which means it can't take any destructive actions. At this point, I had a working MCP server, and I could have said job done, but I wanted to deploy it as a remote MCP server so that it would be accessible over the internet. So with that, I needed to have some authentication. So since I was exposing health data, I couldn't leave it open, so I looked at OAuth to secure it. This actually proved to be the most challenging part of implementing the MCP server, but implementing OAuth is tricky in itself. I used Amazon Cognito as my identity provider, but you could use GitHub, Okta, whatever. One of the reasons I said I wish I used FastMCP, their library, is that it has built-in classes for this and it makes it so much easier. But I got there in the end. And I've got a picture of the flow of the MCP client, it's a bit small, sorry, fetching the auth metadata, redirecting me to the login page where I enter my username and password, and then it returns the access token to the MCP client, and that token gets attached to every subsequent request. It's proper OAuth, painful but secure. Inbound off locks the front door, but now we need to manage how it happens, what happens when the server talks out to Night Scout. Outbound off handles how the MCP server talks to Night Scout on behalf of each user, because this MCP server can actually handle multiple sessions with multiple users. When the MCP client calls the tool, the MCP server validates the inbound token, looks up that user's Night Scout credentials, and then follows the authentication process for the Night Scout API. Implementing OAuth is considered to be a bit of a pain point. A big part of it is because MCP servers can be used by multiple clients, but you need to register each client with the authorization server in a database. This makes it less portable. Solutions are being discussed, such as the client ID metadata documents, which sidestep this issue. So watch this space. Now there is this typical SRE saying hope is not a strategy, so you do need to test it. And the MCP inspector was invaluable for this, for checking everything worked, from the auth flows to the tool discovery to the input and output schemas, all visible in a friendly UI. For professional situations where you want to do your testing in a CI pipeline, there is a CLI mode too. I've also noted down a couple of the alternatives, MCP Jam Inspector, VS Code, MCP Dev Mode, which is really useful, and of course your traditional automated tests. So I typically use MCP servers in work when I'm using them in my terminal or in a code editor, but when I'm on the go, having a meal out, trying to juggle my diabetes needs, I want to just be able to do it on a browser or on any device. So for that, I decided to set up the MCP server with ChatGPT. And you do need to have a premium subscription for this, but you can go into your settings, you can add an app, and you can see in here we have the URL for my MCP server, the OAuth, and then the two tools that are available, so the adding carb treatments and getting glucose entries. Then you can see me selecting it, and then asked it to estimate how many carbs there were in a meal I had out. And then there you go. You can see it's logged into Night Scout 45 carbs, which is very helpful for me. So I have brought us right up to time. Thank you, Risha. In my case, I used an MCP server to help me better understand my blood glucose data, but it could just as easily be integrating your CI/CD tools, your Jira tickets, or any other software you care about. Coming back to the theme of breaking the pattern, part of breaking patterns is building new ones, and this whole experience has definitely inspired me to contribute more to open source projects. I have open sourced this project. Come and chat to me if you're interested in it. If there's something you would like to take part in, there are some open issues in that repo. If you'd like to learn more, I've curated a bank of resources, just links and different sources for my presentation. You can grab them by scanning the QR code. I promise it's safe. And yeah, enjoy your lunch. Thank you.
Awesome. Thank you very much, Eve. As Eve alluded to, it is lunch, but I will allow a question or so if we have one. Or do people just want to go to lunch? Okay. Cool, yeah, it was really interesting. We can tell you've had a type 1 for quite a while for how casually you went, yeah, just a minor hypo, when you were looking at your Halloween data. So thank you very much for that. Thank you.